Great to be here. Thank you all. My name is Miguel. I'm co-founder and chief scientist at Nillion. What we do at Nillion is building what we call the blind computer, which is a new type of Web3 infrastructure that enables Web3 developers to store and compute on private information from their users without, leaking it to anyone, including us. And essentially, I would like to talk today and explore the intersection between privacy and AI. So why do we need privacy in decentralized AI? And I would like also to explore some use cases and also like the technologies, the privacy enhancing technologies that enable us to actually support privacy in decentralized AI. So what is decentralization? The whole story began by wanting to remove control from those who provide services to us, right? And what do they control? Well, they control in the first place everything around the provisioning of that service. They control if and when they will provision that service, so they have the capability to censor us. And they also control the nature of the service. They can change that without us even noticing in Web 2. That has to do with the integrity of the service. Those were the initial motivations for decentralization for Web 3. It all started like that. And it made sense for money and for transactions because that's exactly the major risk that you have when you're dealing with assets. Now, what else do they control in Web 2? They also control our data. The minute you send your data to them, even if they store it on, on an encrypted database and all that, they will have the keys to decrypt your information and actually have access to it in the plain text. They need to because that's a part of the way they provide you with the services. They need to compute on that data. That's another form of control that is also very relevant to decentralization. It's another aspect. What is the difference between the two of them, really? Well, one difference is that all around the provisioning of the service is more or less reversible. Like if I'm not allowed to access a service today, maybe I will be allowed to do so tomorrow if I feel, if I meet the requirements. But if I give away my data today, it's gone forever. There's no way to take it back, to regain control over that data. It's an irreversible process. And common sense, advises us to be very careful with those decisions that are irreversible, like this one, giving away your data. That combined with the fact that Web3, and in this case, AI is really data-centric, is already pointing towards the need to add privacy to decentralized AI. And AI indeed is very hungry for our data. Initially, it was trained on public data. We all know that. So LLMs were trained on data that is publicly available, but that has been already exhausted. We have this scarcity problem. And the way to continue forward for companies is essentially to start tapping into the vast resources of encrypted databases that are sitting behind the firewalls of companies and individuals. Companies as well, right? Because there are many companies with a lot of information about different domains, different verticals, different markets. For example, just think about a company that is specializing in growing crops in certain latitudes. That is something that is probably personal or private information, sensitive information that is sitting somewhere in some company and that would contribute to making an LLM smarter and more useful. So AI companies are already looking for that, are already trying to untap that potential. And there's another type of information that they're looking for, which is our personal information, for two reasons mainly. One, because it will make AI smarter. This is what it takes us to what we call personalized AI. It's a type of AI that knows everything about you, that knows all your context, all your, where you work, what you think, what your ambitions are. So we've gone from content is king to context is king, and the context in this case is you. The other reason why personal data is interesting for these companies is not just because they want to make the services more interesting and useful, but because that will lock you in. The minute you have trained a personal agent on your data, it will be very hard for you to actually leave for another provider. There's a lot of friction in doing that. So for those two reasons, companies are in pursuit of personal data from us, as well as personal data or private data or sensitive data from companies. So we've gone from a place where they were initially battling for our attention, and now they're really battling for our intimacy. And in doing so, they really are after a new type of information. So level one of personal data is everything that is out there about you, is the things you tweet, the videos that you upload, everything that a journalist would find about you if they wanted to write an article. Level two is things that you share with a company. For example, all the browsing activity, your cookies, the data points that you share with them if you want them to provide you with a service. It looks like levels 1 and 2 are fine for people, right? We've been sharing that information for long now, and no one has really made any huge problem out of this. But now we're talking about a whole new different world in terms of the information that we will be sharing with personalized AI. I'm talking about the things that really make you you. I'm talking about, for example, the things you would only share with your therapist. All your emails, all your health records, all your messages, all your voice conversations, your hopes or dreams, what you really think about people, including your mother-in-law and your boss, your cognitive biases, your limitations, how smart you think you are versus how smart you really are. All of that information could literally destroy you as a person and provides a lot of value and power to those future companies over us, because essentially they have the ways to influence us in ways that haven't just been possible before. It's a very scary scenario. For that reason, I would advocate for the need of, for privacy in decentralized AI, in particular in personalized AI. Now, what privacy brings into the equation is the protection of the core assets that you have in decentralized AI, namely the training data sets, the model weights, and the user prompts. So this is not just about protecting us users, it's also about protecting companies that train models and have model weights, and also companies that collect information. In fact, I would say that this privacy is the key that will unlock a healthier ecosystem. I think the ecosystem with AI right now is pretty wicked. It's really bad. And to prove my point, let me just compare it to two other ecosystems or product lines. One is CRISPR, is the gene editing technology. You have essentially 3 steps, each one with different companies. So in step 1, you have companies that are about the creation of the enzymes that actually do the editing. In step 2, you have companies that actually create the vectors, the viruses or lipid proteins or molecules that inject the enzymes into the cells. And in the third one, you have also QA companies doing the clinical trials and so on. The important thing is that in every box, in every step, you have different companies, and you have different companies across all of them. So it's a very healthy ecosystem. With laptops, the market has been longer there. So you have some acquisitions and mergers that have taken place. So you have fewer companies, but still they're different across different steps, which is good. In AI, what do we have? Well, we have a handful of companies, maybe even 3, that control the whole product line, the whole value chain. They do collection of data, they do training, and they do inference. This is very far away from what we need if we wanted to decentralize the space. So why is it a challenge to do so? Well, in the other ones, if you think about it, the assets is not what the companies pass down the line to the next company. For example, let's say I'm Samsung, I'm producing DRAM chips, and that's the thing that I pass on to the next companies in the assembly of core parts that kind of, build the motherboards. That's a byproduct of my asset. My asset is not the DRAM chip. My asset is really the know-how, the factories that I have, the designs, the processes that I have implemented in that factory. And sure, there are attacks on that. There's reverse engineering attacks that people perform on the byproducts from my assets to try to get to my assets, but somehow the whole thing works because they're not always successful, and we have a healthy ecosystem. What is the problem with AI? Well, imagine that I'm a company collecting data, for example, in agriculture. And I've collected a very nice data set, and I pass it on to the next company down the line, which is going to train on that data. What have I done? I have passed on my main asset. That's my value. And it's been handed over to another company which can compete. And once I do that, I cannot make it forget that asset. The same goes for the company specializing on training. It trains with a lot of effort, a lot of money. It passes on the weights to the company running inference. Wrong, problem. You've handed over your asset. So privacy is the thing that enables to allow for different companies to thrive in the different steps here, because they're not handing over their assets, they're protected. And so you're not giving away your secret, and yet you're enabling the next company down the line to do their thing. So privacy is the thing that will enable the creation of marketplaces, both in data collection, in model training, and in inference. How is it really provided, this privacy? Well, you have different what's called privacy-enhancing technologies. You have zero-knowledge proof, you have trusted execution environments, which are hardware-based solutions. You have MPC and FHE. I'm putting it inside of MPC. I will explain how. And you even have federated learning and other technologies, right? ZKP, in most occasions, is focused on the first problem that I mentioned around decentralization, which is around the provisioning of the service. So here the idea is that you want to prove that the integrity of the service hasn't been violated by providing some sort of verifiability. But it doesn't really address the problem of privacy. So let's focus on TEs and MPC, which do address this problem. TEs provide some level of verifiability as well through the attestations. It's a hardware-based solution. It's fastest, is the fastest solution of all of these. So it's like the lowest hanging fruit, but we all know that it has a problem, which is it requires tougher trust assumptions, right? The security model is not that good as the one that you get when you use plain software-based solutions, which is the case of MPC. So rather than focusing on TE, which is kind of the default solution, I'm going to focus a little bit more on MPC and see where the state of the art is in terms of privacy-preserving AI applications. You can build MPC from different building blocks. You can build it from linear secret sharing, but also from different flavors of TE, for example, TFHE or CKKS. Each one has its own pros and cons, but essentially all of them enable you to create, kind of state-of-the-art ways of running inference on AI models, and some of them even training. Garbled circuits is another way, but it's not really used in AI. It's useful for other things, but not for AI. What things can you do with these technologies? Well, you can do all of these that you see on the list. Interesting is, of course, training and inference. Those are very important ones. So I'm going to be focusing on those and specializing on MPC techniques. This is the state of the art right now. There's been a lot of progress made in the last 6 years. So you may hear, and it's true, that these techniques are slow compared to, for example, plain text execution of models. But look at the amount of progress that has been made. Like only 6 years ago, we were only able to work with thousands of parameters in the models. And now we're able to work with billions of parameters. So there's been massive improvement here. You have the main frameworks that you can use primarily in MPC. Ripple and Curl are from Nillion, done in collaboration with other companies. And innovation continues. Like, this hasn't stopped. This is one example. We did in collaboration with Meta and with the University of California. It's called Curl. It's about porting techniques from digital signal processing, so things you would find, like, for example, in JPEG 2000 standard for image compression. We use those compression techniques and port it into, or transform them into, cryptographic protocols that address the main bottleneck that you have when you work with AI under privacy-preserving technologies, which is the evaluation of nonlinear functions, like the activation functions, and also the linear, like the normalization layers. All of those are the bottlenecks because they're really hard to evaluate under PETs. And what we've done is to use these compression techniques, build cryptographic protocols, and we've seen improvements in the 10 times faster than what we had before. So this is continuing, and it's not going to stop. Now, I would like to finish by thinking a little bit of our relationship with AI. I don't think it's going to remain the same as it is right now. I think it's going to be evolving, just like the relationship evolves with a person who joins your company as a junior first, and then as the years go by, that person learns more and more, and you end up actually delegating that, the relationship resembles more of a delegation. So these terms are taken from management theory on how to manage people. Right now, LLMs, they feel like they're under supervision. Like they're this intern, you have a new pair of hands, but you still have to do all the thinking, you still have to do work, you have to define the problems, chunk them down in pieces, then do double checking on the results. It's not really very helpful. Agents are pushing the technology, I would argue, towards coaching, which is the next step. Now you have the agent that is actually doing some thinking on its own. You still are doing the thinking yourself, you still are doing the work yourself, but it's becoming better, right? They're becoming more intelligent and more useful. And the trend will continue through mentoring down to delegation, which is the final stage where you just define like a playground for the agent. Like you say, well, this is where you can freely move. These are your boundaries. This is your budget. This is the information you can access from me. Go and surprise me and plan a trip for me, right? And the agent will go. You don't have to think anymore. You don't have to work anymore. The agent will go and just do that for you within those given and predefined constraints. That is where technology, I think, is taking us. And the interesting thing is what we call the delegation paradox, which is when you try to think of that progression path in terms of privacy and what that means. Now, in terms of privacy, it's clear that the more evolved the relationship, the more sensitive information you're going to be sharing with those agents. You can think, for example, in terms of the army. Like supervision is like a soldier. You give really quick orders to the soldier, and you're not gonna be sharing highly sensitive information. But mentoring or delegation is like with a general. You're gonna be giving some really detailed orders with a lot of sensitive information. The same will apply with us. So the need for privacy in agents is just gonna increase. But the interesting thing is that the need for speedy responses is not necessarily going to increase. Again, from a soldier, you expect really fast responses because they're really quick orders and you're expecting a fast answer. But with a general, you give it more time. You give the general more time to just go and design the strategy and assemble additional resources and structure things around. That is the way that I think is going to play out with delegation. It's already playing out with agents. When we work with agents, we sometimes give them hours to work on their answers because we're more interested in the quality of the answer than we are on the responsiveness of those agents. And that puts privacy in a very interesting point because on the one hand, privacy is going to become more important as AI becomes more intelligent. And on the other hand, AI is going to become more forgiving when it takes to speedy responses and quick answers. And we're going to have more patience to wait for longer answers. So privacy-enhancing technologies within this context do make a lot of sense looking forward into the future. Wrapping things up, we saw that decentralization is not just about service provisioning, it's also about the data. We need to decentralize data, and the answer to that is decentralized privacy. One way to do that is through privacy-enhancing technologies. The problem that they have is that they're not very performant. You have the hardware solution, sure. They have also security problems. But the non-hardware solutions, they mainly have performance problems. There's a lot of progress that has been made. Still progress is going on, so things are looking positive. And I also reflected on the nature of our interaction with AI as it becomes more and more intelligent. And I think it's going to put us in a way where we definitely need to inject privacy into the equation. And also it's going to be a more forgiving situation in some scenarios where we can wait longer to have the answer if we have the guarantees that we're not sharing that sensitive, highly sensitive information with the companies running AI. Thank you very much.